do this. Yeah, I like to do it that way, just so I'm not always right there and just pop right out at you. But good morning, everyone. So, hope you guys are doing good this morning. It's a wonderful, beautiful Friday morning here in central Oklahoma. And we're ready to talk to you guys about energy today, which is fun. This is a topic that I know quite a bit about, so I'll try not to get too windy. I'll try not to go down too many rabbit trails here. But let's just say that what you've been taught about energy and physics and how you work and all that stuff is a nice little tight box. And that it's, the thing about truth, if you're a truth seeker, so I kind of consider myself an alchemist, which would be definitely a seeker of truth. But if you're a truth seeker like me, you know that there's always truths beyond any truth you find until you get to God. I mean, God is the highest truth and God is the ultimate truth, but there's always higher truths beyond any truth that you find. So as soon as you think that you have that rock solid answer, there'll be something beyond it and something above it. So that's the cool thing about how truth works. And with the energy, there's a lot of that because really at the core of it, energy is what defines our relationship with God. Energy is our connection to God, or a connection to God. I don't know if it's the only one, but it's a connection to God. So how we sort of deal with radiant energy is our connection to God. I intend to prove that, by the way, in the course of doing that. But anyway, don't take my word for it, by the way. Never do that. Again, always discern for yourself. But that's just the way that I'm sort of seeing things as I sort of claw through these truths and continue to look for, higher and higher truths. Okay, so blah, 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 blah. Chip, shut up and teach us what you want to teach us. Okay, I'll do that. Here we go. So, I better get this up. All right, it's easier for me to drive when I can't see what I look like when I do this, so it's a little bit interesting. But anyway, so we'll dive right in. We're going to talk about really how our bodies use energy, but this is going to lead to a broader, energetic discussion. And again, I'll try to stay on topic here, but I really want to teach you guys about how our bodies use energy. And things, yeah, that's a fair representation. So fats, carbohydrates, and aminos, I would say, that would be an accurate depiction there. But again, we're told that we need to eat these things. And again, as we eat these things in our body, that provides us energy. So it's like, we understand the concept of putting gas in a car, or having to feed our horse so that it, sort of could go down the road. And that's what we're taught about sort of how we gain energy and kind of how we manage energy. Are there problems with this theory? Yeah, and we'll talk about that. But on the surface, it seems kind of right? So we see animals do this all the time, and, it just seems pretty right. I'm a mathematician though, so it's, there's some thermodynamic laws here involved. So like energy in has to equal energy out. So look, Ma, the math, she no worky. She no worky. So if you look at the item on the left, the amount of energy in an item of food or drink is measured in calories. When we eat and drink more calories than we use up, our bodies store the excess as body fat. That's not right either, but we'll cover that in another video. If this continues over time, we may put on weight. As a guide, an average man needs about 2,500 kilocalories, which equates to 10,500 kilojoules a day to maintain a healthy body weight. So again, we're told that we need about 2,500 calories. If you eat more than that, you're going to get fat. If you eat less than that, then you'll probably lose weight. All of that is a complete lie, by the way. Or it's not a lie, but it's misleading and it's not really right. Why? So again, let's work this out. Okay, so look at the over here on the right. How many joules of energy does a human use? Well, depending on the activity in the environment, the body dissipates between 290 and 3,800 kilojoules of thermal energy per hour. I would encourage you to dig into the differences there, but let's just take an average of 1,000 kilojoules an hour. If you're awake for 14 hours, well, then you're burning 14,000 kilojoules, which is more than you consume with 2,500 calories. So the whole point of this is the math doesn't work. And again, most of us are up in the 3,000 kilojoules an hour, according to the kind of graphic on the right here. And you can look up, kind of what that is. Breathing in and out is probably the 290. Laying, down asleep is the 290, right? Do the math. And I think that you'll quickly find out that, what you consume doesn't work, right, as to what you output. And what that means is that we're gaining energy from somewhere else, okay? Where does this magical new energy come from? Well, let me tell you about some things, okay? So let's go back to a plant, all right? So a plant, we know, gains energy from the sun, right? So plants photosynthesize. We're all taught that in grade school. We sort of learn about that. And we know that plants have chlorophyll. And what chlorophyll is it's a pigment. It's a thing called a pigment. And what pigments do is they absorb energy from the sun. So they take and it doesn't have to come from the sun. It just has to come from a photon, okay? But they take photons that usually come from the sun at a certain frequency, at a certain wavelength that we'll talk about in a second. They take those in and they charge. Basically, the atoms or the electrons that are around the atoms within chlorophyll charge up and they end up popping up in shell. And when they pop up in shell, that's what stores energy. So chlorophyll begins to store energy. And when it stores enough energy, it creates, and it releases it, it creates the photosynthetic reaction that creates energy, okay? But this is done with just strictly light, all right? Well, I want you to just notice something here about the molecule on the left that is called chlorophyll. And you can see the porphyrin ring there. You can see magnesium at the middle. Now, you're a little different, by the way. You don't have magnesium in the middle of this molecule that looks pretty much like this. That's called hemoglobin. You have iron in the middle, but, kind of the same thing. Now, if you know anything about, let's say, if you've ever studied light and how light works, or lasers, or higher energy and how higher energy works, you'll study about something called resonant cavities, because resonant cavities is a way that you can kick up energy. Let's put it this way. Every laser beam has a resonant cavity. Every microwave, where you have to pop up, energy and frequency, has a resonant cavity, because we use resonant cavities to store energy and to step up or step down energy. Well, guess what chlorophyll is, boys and girls? It's filled with resonant rings and resonant cavities. That's exactly what you're looking at in that molecule. All of those little six-sided guys, those carbon rings, are resonant cavities, all right? And the tails on these are sort of, lock and keys that are sort of able to signal and do other things. Chlorophyll, very powerful molecule, very good supplement, by the way. Again, you theoretically, you could run on chlorophyll rather than hemoglobin. So we could theoretically run on chlorophyll rather than blood. Yeah, think on that one. Okay, so where does this excess energy come from? Well, I kind of gave it away with photosynthesis. And again, this is a deeper look at how photosynthesis works. So again, we're looking at the same molecule on the left. If you look over on the right, this is what, in the sort of photon with a lightning bolt there is showing you how a pigment molecule called chlorophyll, or called hemoglobin, or called melatonin, or called keratin, or called a bunch of other ones, how a photon hits that pigment molecule and charges it to an excited state. And how does that work? Well, the graphic there on the far right, you can see how that electron is in an inner shell on the bottom. And as that photon hits it, that electron moves to an outer shell up at the top. And this is how atoms store energy. This is how sort of energy moves, really, is through photon exchange to electron sort of excitement. And then as the electron gets sort of de-excited or less excited, or as that thing wants to give off energy, that electron will drop shell. And when it drops shell, boom, it gives off another photon that has the energy that it was storing, which is really cool. So this is how things resonate and kind of move energy around. But it's a very good example of this is in how a plant, works with pigment or you work with pigment molecules, and you do this. We do this in our skin. But again, that gets a little controversial and all that. So we'll talk about it in terms of a plant. All right, DNA in the sun. The human body is capable of building specialized proteins that transfer light energy into chemical energy. One of these proteins, known as melapeptin, and that comes from melatonin, by the way, uses light energy. Again, you don't have to go find this as a supplement. Your body builds it from melatonin. You need melatonin, definitely, but you don't need this particular guy. But he uses light energy to set our biological clock and may be involved in embryonic development. Light carries energy with it. You can sometimes feel that energy in the form of heat, so we know that. But again, light has a lot more to it than that. Most life forms have evolved to capture and use this energy for various purposes. So again, you'll read you don't really read about us being able to use energy from the sun, to be able to translate energy that we get from the sun into physical work, into stuff that we need. But what I'm telling you is that the sun and our interaction with the sun explains the excess energy that we expend very clearly that we cannot consume in food. Okay? So hopefully you're with me. All right. So hydrogen in the sun, let's drill into this a little bit more. How much does it take, let's say, to excite a hydrogen atom in the way that we're talking about, with a chlorophyll molecule in a plant? Well, this is basically the wavelengths of light that it takes to move a hydrogen electron into different shells, okay? And the smaller is more powerful, right? So to even, sort of create the situation, you need 122 nanometers of light, which is super duper high frequency. That's very, very powerful, extremely powerful to have to be able to do that. And then you look on kind of the other end of the spectrum, so 1024 nanometers of light down there in the Pension series, to move an electron out from, and again, 1875 is even less, to move an electron from shell 3 to shell 4 in a hydrogen atom. So, you're looking at less energy, let's say, as you sort of move out in shells to be able to excite that thing. And so, and this works with all atoms, all molecules, anything that has electrons, which is everything, in the same way. Okay? So, hydrogen atoms get stimulated in this way. Again, what happens when they get stimulated? Well, again, they bond. What makes water? A stimulated hydrogen atom and a stimulated oxygen atom, okay? So this is how things work, how things glue together. But this all happens, and what I want you to appreciate is that this all happens from the sun, right? So energy just doesn't magically... And we get some of these sort of, let's say, radiant energy from other stars, so we get some of this at night. We get some reflected, you know, off the moon and other planets, you know, at night. But the main juice, the main thing that you're getting, and the main very intimate relationship we have is with the sun, which is cool, isn't it? Okay, so cytochrome proteins and light. All right, so does this work inside of you? Well, the graphic on the left over here, it looks, you know, kind of complicated, but that's just photosynthesis over there on the left. But what I want you to look at is down at the bottom, you kind of see the sunlight and the light hitting these photosystems, photosystem 1 and photosystem 2. And you can see that P680 and P700, boys and girls, they named the proteins after the light patterns that stimulate them. So what stimulates a P680 protein? 680 nanometers of light. What stimulates a P700 protein? 700 nanometers of light. So again, it's not like this is a big secret. And again, as these guys get stimulated, so you can see over there on the far left in photosynthesis, I keep wanting to say instead of system, photosystem 2, you can see that as P680 gets stimulated, he gets up and he sort of has these reactions, right, that sort of help. This is basically how a plant is generating energy. So that basically help a plant, you know, build energy. And, you know, the second photosystem feeds the first, right? And you can kind of see that. And the end result here is NADPH and NADPH and NAD+, which are used as energy, ATP. So it's used in the ATP process. All right, so light and how light stimulates proteins to do work. That's what I want you to get out of the thing on the left. So light stimulates proteins, and proteins do work inside of you. That's what cells are trying to make. They're trying to make proteins. Again, what stimulates the proteins? Light. All right. So what a big guy that you have inside of you is something called cytochrome P450. Cytochrome P450 is involved in how we, you know, metabolize all different kinds of things. So this guy is super important to glom onto stuff and, you know, change its configuration and make it less toxic, you know, do all kinds of stuff. But P450 is a big guy. Why was he named P450? For the same reason that photosystem 1, I can't say that word. I'm a stutterer, I'm sorry. Certain things get me. But P700 absorbs light at 700 nanometers. P680 absorbs light at 680 nanometers. Cytochrome P450 absorbs light at 450 nanometers. You seeing it? Isn't it cool? Now, you know, again, you're not allowed to see any of this unless you're a PhD or a, you know, all of that, or a wizard or an alchemist. You know, you have to get pretty high up, let's say, in physics and science and all of that before this begins to make sense. And when it makes sense, then you get siloed, right? So you're not going to be able to study light over here if you're a chemist. You know, that's what laser guys do. You're over here, you know, in a lab sort of seeing how things go together. So things get, you know, we hear this all the time, compartmentalization of information. Well, guess how our education system is set up, okay? Siloed, compartmentalized. Even down to the terms. You know, if you go back to all the terms in physics, all the terms in energy, they all go back to radiant energy. Radiant energy from the sun, from light. Why is this so occulted and hidden from us? You know, I don't know. That's a deep question, Jack Andy. You know, we need to all answer that one on our own, but it certainly is. And, you know, all of this is. So what are you allowed to know about, kind of? Well, we all kind of know about vitamin D in the sun, right? So, I mean, we have to have sun exposure in order to make vitamin D. You can't make vitamin D any other way. You can supplement, and that's not obviously as good as making it from the sun. They're even now starting to ask on health questions. Well, do you spend 15 minutes in the sun every day? Well, why? Because you need to make vitamin D. At certain places on Earth, you really kind of don't do this as well as on other places. And this is what, down at the bottom, you see, that's sort of, they're trying to represent pigmentation with their migration towards the north down there. If you're pigmented, so like, let's say the darker your skin is, seriously, the further south you need to live. If you live north of Oklahoma and you're pigmented at all, you're not getting the amount of vitamin D you need. And you'll be, opportunistic host for bacteria if you're not getting the amount of vitamin D that you need, okay? Now, I want you to look at kind of how this is showing what's getting absorbed in our skin, and then we'll go back to this slide. But you can see UVB 290 to 315 nanometers. Now, that's a more powerful, that's shorter wavelength, so that's more energetic stuff that's hitting us, that hits us in order for us to make vitamin D than what we need for cytochrome P450. So the cool kind of thing about what happens is we take in this light at these really short bandwidths at really high energy, and we step it down through all of these different processes. But one of the processes is making vitamin D, okay? Cool stuff, huh? And again, if you're, well, there's a whole rabbit hole with vitamin D. Again, I don't think you're a mammal. The Bible tells me that God gave me dominion over the plants and the beasts of the earth. It doesn't say he made me a beast of the earth. You're not a beast of the earth, boys and girls. You're not a mammal. You're something a little bit different. We work like mammals. We have a lot in common with mammals. Mammals have a lot in common with fish, doesn't mean you are one, right? So not all mammals are fish, and humans are not mammals. Okay, that was a good transition to this one. So just going to point this out. Again, have an intimate relationship with that big, bright, shiny ball in the sky that we call the sun. We also call Jesus the Son of God. Again, in order for you to gain energy, you have to have a relationship to the sun, and we do. This can be well defined, this relationship that we have with the sun. I mean, we are bombarded every day with energy from the sun, and you can't get away from it, even as a frequency, because the earth is also bombarded with energy from the sun. That's why the earth sings at a certain frequency. If you guys have ever heard of something called the Schumann resonance, the Schumann resonance is this relationship, this node-antinode relationship with the sun. Okay? And you have the same relationship with the sun. How does this work? Musically, which is kind of cool. Okay, so we'll go down the rabbit hole with this just real quick. And again, literally, I could talk about this for hours. And we're actually probably going to get done a little early with this one, which is amazing. But we'll be talking about all of these concepts in way, way more detail, obviously, as we kind of move forward with Chip Talks. And again, I'm just trying to roll out sort of some disclosure to you guys, roll out a view of human health that maybe is a little different, challenge you guys to think a little bit differently, but I'm taking you somewhere. There's a destination, so just bear with me. But we'll go down the rabbit hole a little bit here with this one, because we have to with energetics. And the main thing that I need to teach you is about how you work in your human health, because that's what we need to know right now. It's we could figure out energy later, right? But how it applies to you, and the big thing that I want you to know, you have a relationship with the sun that affects your health. And again, the more that you're kind of aware of that, be in the sun naked, I mean, that sounds silly, but again, that you are furthering your relationship, in my mind, with God when you do that, as you understand that intimate relationship that we have. But we need that in more ways than just energetically. Again, we're getting sort of nutrients that we don't even know about from the sun that we don't even appreciate that we need right now. Okay, so we'll get there. We'll get there. We'll get there. But just be in the sun. If you can be naked in the sun, that's great. The more surface area of your skin that you can have the sun contact, the better. Make sure you're taking vitamins, all your vitamins though, and all your trace minerals, because if we're not taking the right vitamins like vitamin A, melatonin, things like that, then we're not protected from the sun. And that's kind of part of the, again, to go down the conspiracy rabbit hole, part of what's been denied us in our diet and kind of why we get skin cancers and things like that. So it's not the sun. And it's not your relationship with the sun. It's things that we don't appreciate and understand that we need to be consuming as supplements that help sort of that relationship go good rather than bad. That's the best way that I can say it. Okay, so what I'm going to kind of describe next is the work of a very brilliant man that no one knows about named Walter Russell. If you want to read about what Walter did, you can read the Universal One. Good luck. It's truth. I mean, it's a beautiful work, but holy cow, is it a sophisticated read. I'm kind of at the picture level, but you'll love the pictures, and the pictures will, I think, if you're interested and you really want to go down the rabbit hole, the pictures will help unlock some things in your mind that you probably already know. And it's kind of a cool journey. So that is one rabbit hole that's worth going down. Russell's work has been supported by many, many people. Again, he kind of came along at the same time as a guy named Keeley. They were kind of saying the same stuff. Keeley and Tesla were good friends. Rife, sort of in here. The most recent person, though, is this lady named May Waho. And so if you... there's another TEDx speaker that didn't make the big TED in a similar way that I didn't make the big TED, because I talked about the endocannabinoid system. But he invoked Royal Rife, and so he didn't make it. But his name is Anthony Holland, and he works with cancer and frequency. So he kills cancer, or helps kill cancer, with frequency. So in a very similar way that Royal Rife did. But he cites her and her works, and May We Ho, and her Rainbow and the Worm book. Now, she's very well published, PhD, but she kind of sums it up in a book that's pretty easy to read called The Rainbow and the Worm. That's a super duper good book to read too, about kind of everything that I'm talking to you about. So it's not just Chip. It's, there's a lot of people that are seeing the same thing, same relationship, same system, but the way that it works is so cool. So again, energy in the sun. So energy travels in the form of a magnetic standing waves, which emanate from nature for our purposes from the sun. The waves have very short wavelengths and very high frequencies, but they're waves everywhere. There's just constantly we have these interactions, let's say, with these standing waves. As these waves lose energy, they form particles. So as the waves sort of come from the sun and they hit our planet, our atmosphere, our sort of magnetosphere, really, they begin influenced, and as they become influenced, they lose energy, so they sort of deflect and disperse their energy. As they lose energy, basically those are what sort of precipitate into atoms, all right? And so that's kind of what I'm saying in the rest of this. As the particles interact with other waves, they energize and de-energize. As these emissions lose energy, they become more solid and physical. So, it's the first things that hit us aren't necessarily hydrogen. They're smaller particles and more energetic particles. But as they precipitate, they become more solid and more physical. The elements formed by this process, all the molecules, everything here, your physical reality, all of it, forms by this process, and thereby all molecules and matter. So think about what I'm really saying here again, and not just me. It's May We Ho, and it's Walter Russell, and it's Nikola Tesla, and it's Rife, and it's a lot of other people. That as this energy hits us from the Son of God, this radiant energy that potentially is just God's juice, right? It hits us and it literally creates and forms not only our reality, but it has a very, very intimate relationship with you. Okay, so here's where it gets a little cool. So we've all seen Sound of Music, haven't we? Doe a deer, a female deer, Ray, a drop of golden sun, me a name. Yeah, so you know the tune. What that represents, so do, re, mi, fa, sol, la, I thought it was T, but this says C, T, do, is an octave. And guess how energy drops out, boys and girls, in music? So how does, as this energy sort of, as it's losing energetics coming from the sun, coming from other sources, how does it sort of drop out, and where does it, what rocks does it form in the stream, so to speak, and how does all that work? Music, music, music. And what you're looking at there on the left, and this is from Walter Russell's work, but it's just, that's a bar magnet, okay? And that's a bar magnet in terms of magnetic poles, and you can see how it pops out in octaves. If you look at elements and how they absorb light, it just, this is how the elements form. This is how atoms work. All right, if you guys are interested in deeper reading, The Universal One by Walter Russell, good luck. It's worth it, though, to dive down that rabbit hole. It's a tough read. It is not an easy read. The Rainbow and the Worms, a little bit easier read, and that's by Mae Wan Ho. Again, very, very good read, and does take some understanding. She does a very good job of writing to PhDs and sort of other, if you want references and everything about everything, and you want to see the math behind stuff and all that, that's in her book. Walter is theory, he's out there in theory, and Keeley is kind of the same guy. So Keeley would be right up the Walter Russell avenue. And then the last one, this is recent work, a relatively recent work, Irina Kusik. And I think she's a she, but I heard someone else refer to I Kusik as a he. So it may be actually a father-daughter team. But anyway, they are, I think, Eastern European, and they're working on something called the resonant recognition model of macromolecular biology. This is a good read as well. So again, this gives you a way to determine based on a protein. She walks you through how to determine the frequency of a protein. And again, proteins make up neuroreceptors and neurotransmitters. They make up stuff in our body. And this is really the secret of how we can begin to manipulate the human body in very beneficial ways and very targeted ways. So this is kind of what Rife was onto, but in a more destructive way. This is more of a kinder way, let's say, to manipulate things, and it's very specific to proteins. So again, you can definitely use this for good or use this for evil. But obviously I'm trying to teach you about it, and I'm sure that it is being used for evil, in different places. But we can use it for good, and as we understand this, again, some of you know about Rife, some of you may have a Rife machine or mess around with Rife. Well, how do you get to the frequencies? I mean, right now we're all, trading and buying frequencies, and, no one really can tell you where those frequencies come from or how those frequencies are generated. So why should you use 653 hertz, right? Well, again, that model, the resonant recognition model, gives a method for determining what those frequencies should be to affect a very specific thing, a protein or a neuroreceptor. One of the examples that she gives, and one of the research, and I think she's a she, apologies if I'm getting that wrong, but one of the things that they've done, actually in a published paper, is with frequency, they were able to block the ACE2 neuroreceptor. which is fascinating, and that is, you know, prophylactic against COVID. So with just a frequency, they were able to basically protect you from COVID, which is pretty cool beans, right? All right, so that's it for today. Again, we went down the rabbit hole a little bit. There's a lot, obviously, that you can see that's here. We'll be talking about different characteristics of this, of what I've talked about in numerous ways, you know, in the next chip talks. So it's obviously, this is a lot, okay? But we're headed somewhere. So stay with me, boys and girls. So we'll get there. And this all relates to human health. And again, this is stuff you can do at home, isn't it? Once we figure out these frequencies, very much stuff that you can do at home or to help your plants grow or you know, help your beagle, any of that. All right. Love you guys. We'll